experiments and errors. Purpose. The purpose of this experiment is to practice using several measuring instruments and identifying their error, recording result and doing calculations using proper significant figures, representing result in table and graphs and extracting useful information, identifying the source of errors and estimating the relative error.
To the next measuring instrument, which is the Vernier Caliper. The Vernier Caliper has more precision than the ruler, and the precision as written here, it's 0.05 millimeters. We will see where this number comes from. First thing, let's look at this Vernier Caliper. We can use these jaws, for example, to measure the height of our cylinder. You can use these to measure the inner radius of something. So if I need, for example, the distance between these two fingers, like this. And you can use this part if you need to measure a height or a depth using this part. So I'll have to put it like this and until it hits. Basically, this will give me also the height. Now the reading I have to take from here, and this is what we are going to learn. We have two scales here. We have a fixed scale and we have a movable scale. This fixed scale is divided into 0, 10, 20, 30 millimeters. So these are millimeters. So that means the smallest division is 1 millimeter, similar to the ruler. So 1 millimeter is the smallest division on the fixed scale. Now we have also a movable scale, and this movable scale is divided into 10 parts, and each part is divided into 2, which means a total of 20 parts. Now these 20 parts are used to divide each millimeter here, which means the precision, again, 1 millimeter is divided by 20. And if you do 1 divided by 20, you get 0.05. So this is where this number comes from. It is the precision, and this is the smallest division that we have. Now you're wondering, this is not 1 millimeter. Of course, it's not 1 millimeter, but it is designed in such a way that can divide the 1 millimeter. We will see how. Let's start with our exercise. So we need to measure now the height of the cylinder. We remember that it is close to 15 millimeters using the ruler. Now what I'm going to do, I'm going to press as much as possible, and then the reading will be fixed. I can remove it now, and then I have to take the reading. So I'll get closer. Now, you see this is the 0 on the movable scale. This is very important because this is where I need to take the reading. So you need to take the reading that is just before the 0. And this is the 15 millimeter. Okay? Now we see that this 0 is a little bit after the 15 millimeters. And now we are going to use this movable scale to read how much it is here. How much is this reading in between the 15 and the 16 millimeters. So what you need to do is basically you need to find an alignment between the lines here on the movable scale and the lines on the fixed scale. So I'll start from the beginning and try to find an alignment. You see, for example, this line is not aligned with this line, so I cannot choose this. So I have to move, and then I'll try to find a good alignment between the lines. And I think that this line, you see this line here, these two lines are aligned very well. This alignment here is better than the alignment here. So I will take this alignment. So that means now I can take the reading from this movable scale to give me how much it is after the 15 millimeters. So this is 2.5, but it's not 2.5 in fact. This is, as you said, this each one is 0.05 millimeter now. So corresponds to 0.05 millimeters. So that means this is 0.1, 0.15, 0.2, and here 0.25. Okay, 0.25. You remember each now spacing here corresponds to 0.05 millimeter, because as we said, these 20 divisions divide the 1 millimeter, so each one is 0.05 millimeters. So that means this is 0.1 millimeters, this is 0.2 millimeters, and this is 0.25 millimeters. So now let's go back here to the paper, and that we see in the Vernier Caliper here, the smallest possible, the smallest division that we have is 0.05 millimeters. And the error, remember, the maximum error is going to be half the smallest division. So it's half this value, so plus minus 0.025 millimeters. And in this case, the example that we have, we said it is 15 millimeters, 0.25 plus minus the error, which is 0.025 millimeters. Okay. Let's take another example with the Vernier Caliper. And I here put a random reading. And again, the first thing we need to do is to take the reading from the fixed scale. So whatever is before the 0. So 10, 11, 12. This is the reading on the fixed scale. Now be careful. Don't take 13. You don't take any, even this, if this is closer to the 0, don't take it. You need to take whatever before the 0. So this is 12. 12 only, the before the 0. It is less than 13, so I cannot take 13 and then take a reading from the movable scale. So that would be more than 13. It's between 12 and 13. So the next thing, again, this is now our reading is 12 on the fixed scale. The movable scale, I need to find an alignment starting from the beginning. You'll find only one best alignment between the lines. So here I'm moving on. I don't find a good alignment yet. So I'll start to find a better alignment here at the 7. Okay, so I think this is the best alignment, you see. And this 7 means this is 0.7. Remember, it's 0.05 each tick. That means when I reach the 7 here, which is 14 steps, this will be 0.7. So that means our reading is going to be 12.70.
Density of wood. Measure the dimension of the wooden meter stick available at the lab. Use the Vernier Clipper to measure the thickness and the width. Determine the volume of the meter stick. Calculate the density. Recall the density, mass over volume. Record your values in the table showing the proper units and number of significant figures. Given the actual value of the density provided by your lab structure, calculate the relative error in your results.